Hello, this is Mr. Stansbury. I'm going to take you through the notes on key features of quadratic functions. At the end of this, you should be able to say, I can identify and interpret key features of the graph of a quadratic function, and I can find key features of a quadratic function and graph it. Okay, so first things first. To identify key features of a quadratic function, it's usually best to have it in something that we call standard form, which is y equals ax squared plus bx plus c. Okay, so sometimes we're actually going to have to switch the form. So right now this is in factored form, so we're going to switch this into standard form, right? The quadratic function in standard form. So to do that, simply all we want to do is just multiply these two things together. So you can do the little FOIL or the hawk thing. I like to stack one on top of the other. I'm going to take my 2x plus 7. I'm going to stack that on top of the x minus 3. And I'm just going to multiply this thing out. Negative 3 times 7 is negative 21. Negative 3 times 2x is negative 6x. I'll put a 0 in there to hold the space there. X times 7 is 7x. Put that right underneath the other x's, which is the negative 6x there. And then x times 2x is 2x squared. So then we just combine these rows together. We get 2x squared. Negative 6x and 7x is plus x, and negative 21 plus 0 is negative 21. So then we would simply write this as y equals 2x squared plus x minus 21. Okay? Okay. All right, now what we're going to look at is we're going to look at all the other. Now that we have it in standard form, we're going to look at all the key features of quadratic functions. Okay, so this blue graph here is our quadratic function, and there's all sorts of key features that we want to look at. One is the axis of symmetry. That's what cuts this parabola exactly in half. Another part is the vertex, which is either the high point or the low point in that graph. Another point is the Y-intercept, is where this graph crosses through the y-axis. And then the last thing we want to find, or another thing we want to find, are the X-intercepts, where this graph crosses the x-axis. Okay, now over here is going to be ways that we can find each of these four key features. Okay, so first thing, axis of symmetry. If you remember from before, we can find that using the formula x equals negative b over 2a. So you can tell that's the reason why it's nice to have this in the standard form here, ax squared plus bx plus c. Okay, so that's how we find axis of symmetry. The vertex can be found by plugging in whatever we get for x. We take that x value and plug it back into the original equation to figure out what the y is, and that will give us our x. Well, we have the x from the axis of symmetry, and that will also give us the y value of the vertex. So that's how we find the vertex, which we also did earlier on in this chapter here. The y-intercept is simply going to be whatever this constant c out there is, and that's something that's new for us, is to find that y-intercept. So whatever this number is here, that's what our y-intercept is going to be. Okay, as long as we have it in standard form. Okay, and then the x-intercepts can be found by solving the equation for 0. So basically that means what we're going to do there is we are going to factor. We're going to factor this thing out to set it equal to 0. Okay? Okay, so using that info there, let's take a look at an example. All right, so find all key features mentioned for this quadratic equation and graph it. Okay, so let's see. Let's start with axis of symmetry. X equals negative b, which is 4 in this case, all over 2 times a, which is, there's a 1 out there, so that's 2 times 1. So we get x equals negative 4 over 2. So our x is going to be negative 2. So there's our axis of symmetry. Okay. In fact, I'm going to actually go back and redo this here in pink so that it matches up with all of our other colors here. Okay, so there it is in pink, matching up with what we have over here. So axis of symmetry, x equals 2. And you can just write AOS instead of writing out axis of symmetry. Okay, now to find the vertex, we're going to simply plug this x equals -2. We're going to plug that -2 in for all these x's and solve for y. Because f of x really is y, right? So we get y equals -2 squared plus 4 times -2 minus 5. So we get -2 times -2 is 4. 4 times -2 is -8. And then minus 5. So we get that our y value here is going to be what? -9. Okay. So the vertex then, will then be, we already had -2 for our x, and then our y now is -9. Okay. So we're going to eventually have to graph this, so let's just put this stuff on here as we get it. So let me go back. Let's do our axis of symmetry. X equals -2. So there's our axis of symmetry. And then our vertex is at -2, -9. So our vertex is right here. And let's even label it -2, -9, vertex. All right. Next thing it's having us do is find the Y-intercept. So in this case here, the Y-intercept will simply equal this -5. Okay, so that means that this graph is going to end up crossing through at -5. So that's Y-intercept, and that's at 0, -5. Okay, and then let's see, last thing we have to find are the X-intercepts, right? So the X-intercepts we find by setting our function here equal to 0 and basically factoring it, right? So we've got x squared plus 4x minus 5, set that equal to 0. So we're going to factor this thing out. Since there's a 1 out in front here, we can simply go to the last term there and say factors of 5 are 1 times 5. So we know we got x and x, 1 and 5. And then we just have to figure out what the signs are going to be to add up to +4. So it has to be +5 and -1 adds up to our, that adds up to +4, and it multiplies together to get -5, right? So X-intercepts, we have to solve each one of those for 0, right? So we have to have x minus 1 equals 0 and x plus 5 equals 0. So add 1 to both sides. X equals 1, or let's see, subtract 5 from both sides. We get x equals -5. So our x-intercepts are going to be at -5 and +1. Okay? And really, once we have that, we've got a lot of info to be able to come up with our graph there. So we know that, let's see, we know that everything's going to mirror image over here, so that's 2 units away. So we go 2 units over there, and we've got that point there. And we can even say that our slope is up 1 over 1 from our vertex, up 1 over 1, up 1 over 1. And that gives us actually 1, 2, 3, 4, 5, 6, 7 points here for our graph. Okay, so then we do that. And we do that. Try to make it a little nicer than mine, but you at least hopefully get the idea there. Okay? So that's all the key features that you're going to need to know about a quadratic function here and how to graph that. Okay? Let's do one more example, but before we do that, let's take a quick little comedy break. Okay, so let's do this last example here. Find the axis of symmetry, vertex, x and y intercepts, and then graph the function using what you found. So let's do axis of symmetry. which is x equals negative b, which in this case is 6, over 2 times a, which is negative 2. So that gives us negative 6 over negative 4. So we get 1.5 is our axis of symmetry. Okay, now we can use this x value to find our y value of our vertex, because we now know that the vertex... We know that the vertex is negative 1 point, oops, not negative, but positive 1.5. And then we're going to find what the y is here, okay? So we get f of x is what y is. Y is going to equal negative 2 times 1.5 squared plus 6 times 1.5 minus 1. Okay, so in this case, 1.5 squared gives us 2.25. 6 times 1.5 gives us 9. Okay. That gives us negative 2 times 2.25 is going to be negative 4.5 plus 9 minus 1 is going to give us 3.5. Right? 9 minus 1 is 8 minus 4.5 is 3.5. So that means our vertex is 1.5 and 3.5. Okay, so with that, we should start putting some of this stuff in. So we know our axis of symmetry is here at 1.5. X equals 1.5, so it's right along there. This line here. Axis of symmetry, and then we get our vertex is at 1.5 and 3.5. So that's going to be right there. There's our vertex. We'll do 1.5, 3.5. Okay. Y-intercept is just going to be this negative 1 right here. So we know that this graph here is going to cross through at negative 1. Okay. And then last thing we need to do is figure out the X-intercepts. Okay. So now, if you take this here, we've got negative 2x squared plus 6x minus 1 equals 0. We take 2 times 1 gives us 2. Factors of 2 that have a difference of 6, there aren't any, so it's not going to factor. So what we're going to have to do is we're going to have to plug it into the quadratic formula. So here's our quadratic formula, so we're going to plug it into that, because it's not going to give us nice real answers. It's going to give us rational answers of some sort. Anyway, so we've got x equals negative 6 plus or minus square root of 6 squared minus 4 times, I should put that in parentheses, a, which is negative 2, times c, which is negative 1, all over 2 times negative 2. Okay, so we get x equals negative 6 plus or minus 6 squared gives us 36. Negative times a negative times a negative is a negative. 4 times 2 times 1 is 8, all over negative 4. So x equals negative 6 plus or minus 36 minus 8 is 28. Right? Yep. All over negative 4. 28 actually breaks down into 4 times 7, and 4 is a perfect square, so this is going to be negative 6 plus or minus 2 root 7 over negative 4. Ignoring the root, negative 6, 2, and negative 4 all have common factors of 2. In this case, to make our life a little bit easier, let's divide all these by negative 2, so then we'll get rid of the negative in the denominator. Negative 6 divided by negative 2 is positive 3. Plus or minus, that's going to be negative, but since we're adding and subtracting it, we don't need the positive or the negative because it's already got it in there. So we'll do root 7. All over negative 4 divided by negative 2 is 2. Okay, so those are our X-intercepts. Normally, this will work out a little bit nicer so you can find them easier, but this one didn't. So let's do this. Let's plug this into the scientific calculator here, and we can actually calculate what the actual x-intercepts are, just to make sure that we're doing okay. Excuse me. Sorry. So let's do a fraction here, and we're going to do 3 plus square root 7 over 2, and we get an unhelpful answer, but then we push this little button here, we get 2.8, we'll call it, because we can only get so fine on this one here. So we got 2.8, so there's one of our x-intercepts. And then let's go back in here, and then we will do 3 minus root 7 all over 2 will give us something that's not helpful, but then we push this, and then it gives us 0.2. Those are our 2 x-intercepts is decimals, so 0.2, so about right there. Okay. And then that gives us 1, 2, 3, 4. We can actually get our 5th one here by reflecting this point straight over this line. This is 1.5 away, so add another 1.5, and it takes us out here. So now we have our, oops, missed it again. Let's go to there, and go to there, and there is our graph. Okay? Okay, that should be all that we need on this here. If you have any further questions on any of this, please feel free to ask in class. Thanks.